Today's episode is about token-based replay, the first conformance checking technique. Now, as usual, we have our model. So if you look here, we have our model. And then we have our log, the different traces that you had in our real life. So we have this one, and this one. So this one is following the model that we had already. So it's following the model, no problem. But then we have these two traces, which are problematic because we are missing the check. So the check is missing. And also we are missing the ship and the invoice part in this log, in this trace, sorry. And in this one, we are missing also some events. So we have two questions. First of all, does reality match the model? And second question is, and if not, exactly where does it break and how badly? So we're gonna use the example that we usually use. We have the same example. We are receiving an order. The order is the case. Here, if we approve, as here explained, we have two things that happen at the same time, which is prepare shipment and send invoice. And both must finish before we close the order. We need to hold that in your head for the rest of the video. And as usual, we draw our Petri net. We are going from left to right. We have our start place and our end place. The circles are the places. The squares are our transitions. And the token explains the state where we are currently. As usual, we have the same firing rules. If we have a token in one place and then a transition in the middle fires, then the token is consumed and then a new token appears on the other side, just as it's shown right here. So if I play the token game freely, the net is in charge. I am firing whatever that is enabled. And as long as I build my Petri net in a sensible way, nothing can go wrong. But that tells me nothing about my real log. So if I do the replay, we are flipping the control. I'm forcing the net to fire the transitions that I'm finding on the log. And when the trace demands a transition that is not enabled, I am adding a token that I'm creating to force the execution of the trace. That's what we call a missing token. So we have already spoken about that in the PetriNet video. Now we're going to explain it again. So actually we have four counters. First of all, the produced tokens. So it's every token created by firing plus the one we drop at the start. That's the first counter we have. Second of all is the consumed tokens. It's every token replay removed by firing plus the one we pull out at the end place. Third is the missing. It's every token we had to fabricate because the trace demanded it and it wasn't there. So that's what I explained previously. Fourth is the remaining. So it's every token still sitting in the net after the trace ends. So it's produced but never consumed. So this is the formula for fitness. One thing to remark is that you have this first part, which is punishing the trace doing something the model says it couldn't. And then you have the second part, of course, where what we are punishing here is the trace leaving obligations unmet. And let's say you have M and R, which represents the missing tokens, and this represents the remaining tokens. If they are at 0, we have clearly a perfect run, and the fitness will be 1. So right now I'm just gonna play for you how it would look like if you have a trace that's fitting the model. So as you can see, it's progressing. Here, no problem. Every time there is a produced token, it's increasing by 1. Every time there is a consumed token, it's incrementing by 1. And we reach our end place. So as you can see, fitness is 1. We pull the token out of the end place. So that increments the consumed token by 1. Never forget that. And you have the missing tokens at 0, the remaining tokens at 0. As we have discussed previously, that means the fitness will be at 1. Now we're going to look at the deviating trace. So the beginning is simple. It's the same thing as previously. But here there is a problem. So let's say here, instead of having both prepare shipment and send invoice, we only have prepare shipment. So we are gonna go into this place. We have a token at the place of ready to invoice. And the trace, what the trace is doing is that it's actually going to the end place. This means what we're gonna do is that we're gonna have one missing token. Why? Because here, when we try to, if you look here closely, here we needed to have this execute fire so that we can reach this end place. So to do that, we needed to have a token precisely at here. But that's not feasible because send invoice, if we look at our trace, did not fire. So that means we are having one missing token. And the other problem also is that now when we pull out here the token from the end place, we are gonna have one remaining token, which is here. So we're gonna have to increment both the remaining and the missing token by one. If we calculate the fitness, we're gonna have this number, 0857. What's nice about process mining is that, as you can see here, from where we have a token that is being stranded in the middle of our model, and also from the fact that we had to execute here and we didn't have a token here, as previously explained, we can explain what is wrong about our trace. So it's very deterministic, and we are explaining precisely where our real life log went wrong compared to the happy path. So one thing to keep in mind about fitness is not a representation of how good the model is. It's just asking whether the model can reproduce the log or not. It's as simple as that. You have other factors that are also very important, which are precision, generalization, and simplicity of the model. Now, I'm going to give you an example to explain how fitness is not the most important variable to calculate. You have other important things. For example, let's take this flower model. This flower model always has fitness 1, no matter what. But precision is going to be at 0.25. So the perfect score on a flower model is a trap. And sometimes you could have amazing fitness scores on really bad models. So that's another question we need to solve. So one thing you need to learn is that you have your reality and you have your model. The deviation just tells you that there is a problem between the model and the reality. They don't conform to each other. So here lies the issue. Should I fix the process? Should I fix the log capture? Is there an issue from that side? Or should I fix the model? Or the model is not conforming to reality? So that's up to your call as an engineer, of course. Let's look a little bit at code. So here we have the 3 lines of code that are interesting to us. So the first one we have already discussed. It's to discover the model. So that one is clear. Second one is conformance diagnostics token-based replay. So what's happening here is that you have your log, and each line of your log, you have your traces. So your traces are nested in your log. And for each trace, you are calculating the following values. So you have, first of all, this is a Boolean. So it says either true or false if your trace is fitting to the model or not. So if it's 1, if the fitness is 1, you get true, else you're gonna get false. Then you're gonna get the fitness score here. After that, you're gonna get a dictionary. So missing, consumed, remaining, produced. So the counted tokens that you have already discussed. And finally, what's very interesting are transitions with problems. You actually get which transitions you had to create extra tokens, or in which transitions you had the remaining tokens. So this one is actually very important for us. And also here you can have your fitness token based replay. This is what the output of the function gives you. So I'm not gonna get into details about each one of these values, but you have your average fitness, your log fitness. You can see all of that in your documentation. So to recap the full video, here we have a model. We are forcing a real log through it. Then we are counting our variables here. We're counting what tokens were produced, which ones were consumed, which ones are missing, which ones are remaining. And you get a fitness number. Also, what's nice, this is to know, is that which ones are problematic. So these ones in our examples were problematic. The send invoice and close order. So for next video, I want you to predict if this order had also skipped the credit check. So if, let's say we had a trace and it had skipped this one, where does the missing token land and what happens to fitness? So work it out in your head, think about it, because next video will be conformance checking and alignments. If you like the video, please like and subscribe and follow me on LinkedIn.